Ever wonder how your phone recognizes faces in photos? Or how shopping websites seem to know what you want before you even click?
It's all thanks to AI, right?
Exactly. And on that note, we're taking a deep dive into a landmark moment in computer vision, the story of how a deep convolutional neural network wowed the world back in 2012 at the ImageNet competition.
This wasn't just some techie showdown. No, this was big. This breakthrough really set the stage for almost every image recognition technology we use today.
So ImageNet, the challenge, what was it all about?
Imagine teaching a computer to see like we do, recognizing objects, animals, all those things we take for granted. ImageNet was the ultimate test. It was a massive data set with over 1.2 million labeled images. Can you believe that?
1.2 million, wow.
And get this, it spanned 1,000 different categories.
Okay, that's a lot of data,
yeah.
Especially back in 2010. It must have been a game changer.
Oh, absolutely. Before ImageNet, other image data sets were, well, tiny.
Yeah.
Tens of thousands of images at most. This was completely different. Really pushed the limits of what AI could handle.
And that's where our star of the show comes, in the convolutional neural network, a CNN. What makes these things so good at image recognition?
Think of a CNN like an artificial brain, but specifically designed for images. It has these layers of, well, we call them neurons, and they learn to pick out features and patterns, kind of like how our own visual system works.
So this research paper we're looking at today, they figured out how to train a really powerful CNN on this gigantic ImageNet dataset. But CNNs weren't new back then, were they?
You're right. CNNs existed before this paper, but they were so computationally demanding, training them on such a huge data set, a real challenge, expensive and so time-consuming.
But this team from the University of Toronto, they cracked the code, didn't they? They found some really clever workarounds. What were those aha moments that made this model so groundbreaking?
Well, get ready for a few technical terms, but I promise it's worth it. One big change was using something called ReLU neurons, basically ditching the old, slow way of modeling neurons for a much faster method.
So we're talking about making AI learn faster, right? How much faster are we talking?
Think 6 times faster. A 6-fold increase in learning speed.
Wow. That's incredible. So instead of a research project taking, what, years, this could cut it down to months. Imagine what that unlocks. What else did they do?
Well, on top of that, they trained their model on 2 GPUs at the same time. 2 brains working together to crunch through all that data.
Double the brain power. I'm sensing a theme here. Faster, more efficient, more powerful. Anything else?
Another smart technique they used was local response normalization. It's actually inspired by how our own brains process visual information. It basically makes the model less sensitive to, let's say, variations in lighting and shadows in images. Leads to fewer errors.
Like how our eyes adjust to different lighting so we aren't overwhelmed or blinded when we go from indoors to outdoors. That's brilliant.
Exactly.
Anything else?
One more thing. They used a technique called overlapping pooling. Now, that might sound complicated, but it boils down to this. It helped improve accuracy and also prevented the model from just memorizing the training data, you know.
So it wasn't just cramming information. It was about genuine understanding. Very clever. But with all this firepower, wasn't there a risk of overfitting? I mean, this model must have been massive.
You're spot on. This model was huge for its time. 60 million parameters. And with that size, comes the danger of overfitting.
It's like becoming valedictorian by memorizing a textbook, but then you blank on the final exam when you see new questions.
Right. How did they keep this powerful model from becoming a one-trick pony?
2 things. Data augmentation and dropout.
Okay, so let's start with data augmentation. What is that?
Basically, instead of just using the original images, they got creative. They created tons of variations of those images, flipping them, cropping them, changing the colors. Imagine showing a kid pictures of a cat from every angle imaginable. So the AI couldn't just memorize specific pixel arrangements. It had to actually learn what makes a cat.
Yeah, exactly. And then there was dropout.
Dropout? What's that?
It's kind of like shaking things up during training. They would randomly turn off some neurons during the process.
Turn off neurons.
Yeah.
Hold on. Don't we need them all firing for this to work?
I know it sounds strange. But this forced the remaining neurons to step up, learn more robust and general features. Imagine cross-training a team so anyone can step in if someone is out. It's about building a more resilient system.
That's fascinating. I wonder, did this idea of dropout, did it catch on? Did it impact other areas of AI research beyond just image recognition?
That's a great question. And as it turns out, it did. Big time. Dropout, it really took off. Became a widely used technique, actually.
Really?
Yeah. In deep learning, I mean. And not just for image recognition, natural language processing, speech recognition, you name it. Dropout's probably in there somewhere.
Wow. Talk about a versatile tool. But okay, enough about the technical nitty-gritty. Let's talk results. How did this model actually perform in the ImageNet challenge?
In a word, they crushed it. Significantly lower error rates than anyone had ever seen.
Okay, but how much lower are we talking here? Give me the numbers.
They got it down to a 15.3% top 5 error rate.
So that means what, like 85% of the time it was getting the correct label within its top 5 guesses?
Yay.
Which, I mean, that doesn't sound perfect.
For 2012, that was unheard of. That was a turning point, a new standard.
So this wasn't just a one-time win. This had implications far beyond this competition. Why should anyone care? Even those of us who aren't, AI experts. Why was this particular research paper so important?
This was a watershed moment. For computer vision as a whole, it was the start of something big, a new era for deep learning applications.
Give me some examples. How does this actually change things in the real world?
Okay, think about facial recognition. Remember those clunky early attempts that, they barely worked? In this research, it made facial recognition fast and accurate enough to actually use every day. Unlocking your phone, tagging friends in photos, it all goes back to this.
Wow. So that's a direct line from this 2012 research paper to something most of us probably use every single day. What other applications were influenced by this?
Oh, so many. Medical image analysis. Think diagnosing diseases from, say, x-rays or scans, revolutionized the field. Even those eerily accurate product recommendations you get online. Yep, that's at this research too. It's everywhere.
It's amazing to think these researchers back in 2012 toiling away on their algorithms, they probably had no idea, right? How big of a deal this was all going to be.
It's true. That's the beauty of science, right? The impact of breakthroughs like this, it just ripples outward farther than anyone can imagine. And it wasn't just about these specific algorithms. It was about showing what's possible. Deep learning, massive scale. It ignited this wave of new research and innovation that's still going strong.
So it was a big deal, but it wasn't the finish line, was it? Where did things go from there? What's next for AI and computer vision?
You're absolutely right. And the researchers actually said it themselves. This was just the beginning. In their own words, they wanted to eventually use, and I quote, very large and deep convolutional nets on video sequences.
Whoa, hold on. Analyzing video with these powerful AI models. What does that even look like?
Imagine AI that can not only, understand a picture, but can interpret the entire world of video, identify actions, predict events, even comprehend complex scenes as they unfold in real time.
AI that can actually see and interpret the world like we do?
Yeah.
That's incredible, the possibilities.
It's true, but, and this is important, it's not just about building bigger models, feeding them more data. We still need to grapple with some fundamental questions. How do we make AI more robust, more adaptable? Less prone to bias? These are big questions.
It's about pushing the boundaries, absolutely, but also making sure those advancements are, responsible. Progress and ethical considerations, they have to go hand in hand.
100%. AI that augments our lives, enhances them, not something that operates in a vacuum. Human values, understanding, they have to be part of the equation.
And that brings us to our final thought for this deep dive. Something to leave our listeners pondering as as we all navigate this increasingly AI-driven world. This research paper, it really sparked a revolution in computer vision. But it was all about teaching AI to see the world by, labeling images, putting things into neat little categories. What if we could go beyond that?
Go beyond labels.
Yeah. What if AI could understand context, relationships, even emotions in images, sort of like how we experience the visual world?
Now that's interesting, moving from just recognizing objects to, a deeper understanding, more nuance.
Exactly. So instead of just seeing, like, a cat, the AI could understand that the cat is curled up next to its owner, conveying a sense of, comfort, companionship, the whole story within the image.
Yeah, I see what you mean. It's like, it's not just about what's in the picture, it's about what the picture is actually saying.
And think about it. That kind of AI, it could change everything. Photography, art analysis, even helping us design better, more intuitive interfaces for everything.
It's true. We're talking about AI that can interpret emotions, understand subtle cues, maybe even predict human behavior based on visual data. That's a lot of power.
It is powerful.
Mm-hmm.
And that's why this research, the ImageNet paper, it's so important. It's not just about the algorithms themselves. It's about what it represents, the doors it opens.
It's about pushing those boundaries, yeah. But Like we were saying before, it has to be done carefully, thinking about the ethical implications every step of the way. That's critical.
We want AI that helps us, that makes our lives better, not something that operates without any human values or understanding.
I think that's a good place to leave it, don't you?
I do. So to our listeners, next time your phone recognizes your face in a photo, or you read a headline about the latest AI breakthrough, just remember, it's all built on the foundations laid by those researchers who took on that ImageNet challenge.
Back in 2012, it's amazing when you think about it. They tackled an impossible challenge one pixel at a time. Who knows what we'll see in the years to come?
That's right. And on that note, we'll wrap up this deep dive into the world of AI and the ImageNet breakthrough.
Until next time, stay curious, everyone.